This video continues the development shown in my previous video, Smart Robo Hand. After integrating sensors into robots, right hand, the next step is active orientation control. Using an integrated IMU, the robot measures roll and pitch in real time. Two closed-loop PI controllers then adjust the wrist servos to compensate for movements of the shoulder and elbow. The smart hand no longer follows only predefined positions. It actively stabilizes its own orientation while the arm is moving. This is roll, and this is pitch. Here, the outer shoulder joint is moved manually. This rotates the hand, but the active, roll stabilization controlled by a PI controller compensates the movement. For the development and validation of the controllers, I created a small test program. It can generate controlled disturbances using selected joints, the elbow for pitch and the shoulder for roll. In the hand animation, roll is shown in blue, pitch in green, and yaw in red. Yaw is displayed but is not actively controlled. The disturbance generated by the shoulder servo is not compensated because the roll controller is still inactive. The blue line shows the roll angle relative to the horizontal. Now the controller is activated. It keeps the hand parallel to the work surface at all times, which means that the roll angle should remain close to zero. Please pay attention to the blue line. Here we see the second controller, which actively keeps the hand's pitch angle constant. In this case, the disturbance is generated by the elbow joint. The green pitch curve can now also be seen converging toward zero. Here we can see the movement of the unstabilized hand while the robot moves its shoulder and elbow simultaneously in a random pattern. The blue and green lines show the resulting roll and pitch motion. And now, both controllers are operating simultaneously. Roll and pitch are regulated to remain close to zero while the robot moves its elbow and shoulder randomly. I hope it is clearly visible that the hand now aligns itself parallel to the work surface in all situations. The controllers are currently tuned close to the stability limit, where oscillations can begin to build up. This is intentional because I am particularly interested in understanding these stability boundaries. Admittedly, this is not the most popular topic, but it is another important building block for achieving precise and controllable motion in robotics. The results can be applied to tasks such as playing board games and developing more advanced haptic capabilities.